This section's on 2.4, tangent and normal line. So we're going to continue what we just did yesterday, and we're going to find the tangent and normal line. So in this first example, we're going to find the slope first, we're going to find the tangent line, we're going to find the normal line, and we're also going to use what we did yesterday, which was that limit as h approaches 0 of f of a plus h minus f of a all divided by h. And we mentioned yesterday we cannot substitute of h of 0 in there, because if you do, then you're going to have an undefined slope. Okay? So let's do part A. So part A then again is that f of a plus h minus f of a. We substitute it into all the x's right there, so that's going to give us this part right here. Okay? So then from here, let's go ahead and do the algebra. So the square right there tells me I need to distribute this out. If we distribute this out, you get a squared plus 2ah plus h squared. And then on this right here, I just got rid of the parentheses. That gives me a squared. So we're going to distribute this negative into this part of the parentheses. That gives me negative a squared minus 2ah minus h squared, and then minus 4 right there, and then plus a squared, right? Because it's negative times negative. Okay? So this is great. The 4's will cancel each other out. A squares will cancel each other out. Beautiful. So we're left with is just the middle part right there. So the middle part right there, again, you ask yourself, can I cancel out or can I substitute the h of 0? No, you cannot substitute h of 0 because then still you're going to have an undefined slope. So probably there's another algebra step that you can do. Like, for example, looking at the numerator, I can factor out is an h, right? So we factor out an h. The h's then cancel each other out right there. And then you're left with is negative 2a minus h. Now I can substitute h of 0 in here because that's not going to give us an undefined slope. Okay? I'm left with negative 2a, and we learned from yesterday, a can also be substituted with the x that's given in the problem. So that means that slope is equal to negative 2. Don't forget negative 2 because we're going to use that for part B. All right? So let's go on to part B. So part B is asking us to write the tangent line equation of this curve, the 4 minus x squared. So the 4 minus x squared is an upside down parabola, right? So here's my upside down parabola right there. And then this right here is a tangent line. So by definition, a tangent line touches the curve at one point right there. Okay? So that's what the definition means. So when we look at this line right there, we can also see that line is a linear equation, which means that I can actually find the equation using the point slope equation, right? So using the point slope equation from part A, I know some information. For example, I know what x is equal to. I also know what m is equal to because we found out that's equal to negative 2. We don't know is what the y is yet. But we can figure it out, right? Because we learned from last year, when we have f of x, this is the same thing as y is equal to all of this right here. So if I know x is equal to 1, I substitute it in here, we know y is equal to 3, right? So with that information, we put it into the point slope equation. We're going to go ahead and distribute the negative 2 out, combine my terms, right? And then we're going to get negative 2x plus 5 is the final equation. Plus 5 is the y-intercept right here. Negative 2x is the slope. So that means I'm running 1 down 2. Running 1 down 2. That's about right. On that tangent line right there. Okay? So that's how we come up with the tangent line equation. Now let's do part C. So part C is asking us to find the normal line equation, which is then the opposite of the tangent line. So in a normal line equation, it means that you're finding the perpendicular slope. So as we learned last year, perpendicular slope means, by definition, there's a 90 degrees angle difference between the other line right there, right? So which is in our case a tangent line right there. So this perpendicular slope is also secant to the curve. So definition of secant means it touches that 2 point right there. So that's secant, okay? So let's go ahead and find this normal line. So again, this normal line is a linear equation. So I know I can use the point slope equation again. From the information that I found in part A and part B, we know x is equal to 1. We also know y is equal to 3. But in this case, we're going to have to change the slope, right? Because by definition, when it's perpendicular slope, it's a negative reciprocal. So if you remember in part A, we said the slope is negative 2. So then the negative reciprocal of that will have to be positive half. So with the positive half, again, that's enough information to substitute into point slope equation. So if we do that, distribute the half, right? Bring the 3 over on the other side, combine like terms, then you're going to get is y equals 1 half x plus 5 over 2. The 5 over 2 is about 2.5, which is the y-intercept right there. The 1 half x means I have the run 2 and up 1. Run 2, up 1. So that's going to give us this line right here, which is the normal line. Okay? So going back again, definition, tangent means it touches the curve at one point. And then then you have this a normal equation, which is perpendicular to the tangent line. So you're going to have as a negative reciprocal on the slope. Okay? So go ahead now and do the classwork.